Hi everyone, thanks for joining us for today's webinar. I'm Kate from CloverDX and I'll be helping out in this session where our Senior Solutions Engineer Calvin Cortez will take us through the basics of the CloverDX Data Management Platform and show you how it could help you manage your data processes. Just before we start, a couple of admin things. If you've got any questions as we go through the session, we'd love to answer them. Just drop them in the Q&A box on your screen and we will hand those over to Calvin at the end of the session. And we will be sending out the recording of this via email afterwards. And so with that, I'll hand over to Calvin to get started.
Thank you so much, and thank you all for joining. As Kate mentioned, today we're going to be going over CloverDX as a data management platform that can sort of help you get to your ideal data scenarios. We'll begin by sort of looking over some of the companies that we work with and within. These are just a few of our different clients that have successfully used Clover to help transform how they use data within their organization. CloverDX is both a mature data management platform that we use to build data pipelines, as well as a full solutions delivery and customer enablement team. We basically have an in-house suite of different consultants and developers that can help you sort of sketch out and create your sort of ideal data scenario. When we're talking about enterprise level data management, really what we're talking about is providing the pathways to integrate data between applications and business processes. This includes both your sort of traditional business users as well as IT developers. And really what we're trying to do here is ensure smooth, fully automated flows of data. Some example use cases include data ingest, data quality, discovering, mapping, and transformation, anything related to do with the life cycle of data from inception to use to disposal. Here, we're really focused on increasing developer productivity. So we allow you to reuse components and blocks of logic in sort of a visual drag and drop palette to boost productivity. And part of that sort of giving our less technical colleagues more power by building and neatly adapting components for them to use and adapt to their own use cases. We can break down complex jobs into simpler, more manageable parts to improve quality, teamwork, and transparency, while also building templates and frameworks that speed up delivery of new projects by allowing non-developers to sort of customize and configure their sort of already proven implementations to their own uses. Here at Clover, we try to sort of solve 100% of the problem, not just the easy 90%. There's a lot of ETL tools and similar tools out there. And the 90%, like something like a simple lift and shift or a simple migration, taking data from someplace and putting it somewhere else, is really easy and can happen, in 90% of our competition. But really, where Clover comes in handy is sort of dealing with exceptions, errors, outliers, modeling, and executing on really complex processes. So that's really what we're focused on. It's built in a very flexible, sort of agile platform, so that everything can sit on a single platform, and it's flexible and allows you to basically fill in any existing gaps in your technology stack. By combining the capabilities of coding with the readability of visual design, it lets developers solve hard problems in code while empowering, again, our less technical colleagues in a way that's sort of, self-describing, self-documenting data pipelines. And every part of CloverDX can be customized, versionized, parameterized. The point here is that there is no I can't with CloverDX. It's extendable to the 100% of a problem. Here at Clover, really try to focus on sort of automating everything as much as we can. Thinking, hey, let's try to have this and all these processes run on autopilot. We allow you to automate the entirety of all your data workloads to include intricacies of real-life processes and schedule jobs for delivery to data warehouses, operational DBs, either in the cloud or on-prem. And allow you to orchestrate external systems and tools by having sort of CloverDX sit at the center of your architecture. Events, API calls, or message queues can all be used to trigger these different jobs and automate them. CloverDX is made up of two different parts. The first one's CloverDX Designer, which I'll show you guys in a moment, is an IDE for data jobs. It's basically a SIG client that would sit on a desktop of a developer. Well, they would design, debug, and code these different data transformations, pipelines, or jobs. And once it's sort of in a good working state, that job gets deployed to CloverDX Server, which is our operations platform. It's essentially a web application that sits wherever you'd like to host it. So again, on-prem or in the cloud. and we sort of automate, orchestrate, interface, and scale it out to a full sort of enterprise level data backbone of an organization. And that's the idea here, is sort of creating that automated, orchestrated event so that all of our data pipelines can execute successfully. At a high level architecture, Clover sits between different data sources and targets. So example sources include any database, JDBC driven or NoSQL DBs, things like that, Mongo, Neo4j. Flat files, this can be XML files, CSVs, anything really. And it can be sitting anywhere, right? So it can be in FTP sites, SFTP sites, S3, Amazon buckets, whatever it may be. And then actual other applications, other web applications, like REST APIs. So, but the idea here is we're building jobs in Designer, deploying them to server, and then the server is going to grab data, transform it, do what we need to do, and push it out again to the necessary requisite targets as well. So that at a very high level is what CloverDX does, and what we're capable of doing. We really try to sort of design data pipelines and processes using flexible coding approaches that allow us to package, share, and reuse components. So just in a way to, again, quicken up the pace of development. Automate via orchestration beyond just sort of data transformations. Think more in the area of reusable templates that we can reuse to sort of save time. We operate in any environment that includes cloud or on-prem using whatever data ops, pipeline or data ops philosophy that you guys decide to use. We can follow that. We allow you to publish and create your own APIs beyond sort of standard connectors using things like data services and data apps to create a full sort of flow of data. With that, let's go ahead and get into a demo, show you guys around. I'm going to start off here in the design environment. Really simple. This is sort of, here where you're going to use components to like different readers, writers, transformers to create and stitch together these different data pipelines, right? So in this case, I'm actually reading from 3 different sources. I'm reading from a API call, right? So I'm actually going to a location on the web where I can actually spit out an API request using the get method and grab a JSON response that way. I can read a CSV file sitting here on disk, and I can also reach out to a database somewhere and grab data. Eventually, we're going to grab data from our 3 different sources. We're going to have to sort of transform these records into a desired format. So there's a couple different ways to do this. I'm going to go ahead and run this so you guys can sort of see the logical flow of data. But in this first one, as I'm running it, the first thing that's coming from this API is going to be a sort of string, one single JSON string, right? So we're actually going to go into this component. Just an example of some of the things that our components can do is we allow things that are traditionally very sort of difficult and cumbersome, like parsing JSON, and make it very easy to do in sort of a visual format, right? So I can see the tree structure of this JSON object. I can look at specifically what I'm interested in, these specific attributes, and I can then go through and sort of visually drag and drop them over to map them out to my output, right? So what that looks like is like this, I can grab the information I'm interested in, the rest can just sort of stay here, but I can basically grab what I'm interested in. So that's an easy way to deal with, for example, JSON. And then I'm going to flatten that out right into like a single response that's sort of, looking more like what I want for at the end here, my Postgres data warehouse. That's actually the target over here. Along the way, again, we have different files incoming here. I'm going to use a reformat component to transform this from that JSON output, right, into that Postgres DB output. And I can do this a couple different ways. I can either, again, sort of visually drag and drop this in between, grab a function here, things that are, for example, like string to integer. It's really helpful if I'm trying to transform from a string to an integer, right? Because that JSON response came back as a string, but my target format is going to be an integer in this case. So that's one way I can do it. I can sort of visually, stitch together this transformation. or I can go into the source code. This is basically a language called CTL, which is our own proprietary data transformation language. It's really tuned specifically for data engineering or data transformation. And the idea here is that we're able to call on these different functions, like again, string to ensure, drag and drop them here and sort of script them out to do more complex things. In this case, I'm sort of transforming different pieces into my required output. But the main idea here is we're sort of able to script out explicitly how we want things done. So I can either do things via code approach in a scripting language that's very similar to JavaScript or Python, or I can go through and visually transform these. So sort of works for either your very, traditional software developer engineer, all the way to, more business oriented users as well. So we try to make it easy to use. We're going to gather these records, deduplicate on a key, and then push out eventually 1,300 records to our data warehouse, just helping us sort of get through all this in a way that is just easier to deal with versus trying to script this all out explicitly, right? And that's sort of the idea here, is we're able to make this a lot easier than usual. So that's just a quick rundown of some of the possibilities with CloverDX. In this sort of design space. The way that this works is that all this gets condensed down to XML code. That's then going to be basically sent to our server and deployed there to run these actual jobs, right? So when I ran this job here, it's running here in sort of debug mode where I can sort of see it visually running. But there's ways for me to take, for example, this data pipeline or something similar to it and really create, fully automated flows of data that can be triggered quite a few different ways. So the way we'll go through those is actually on the server side. So go ahead and open that up. The server, when you open it up, looks like this. Mine's sitting on localhost, but again, like I said, it can be hosted on-prem or in the cloud. But the idea here is you're able to get sort of health and status of different jobs that I run. For example, I just ran a job for you guys here at this time. It'll let me know sort of the load on the server, how much I sort of taxed it, the data throughput, how much data is coming through, and the CPU load as well. So lots of different sort of options on looking at sort of the health and status of your server. Every time you run a job, you're keeping an execution history here. So for example, I just ran this job for you guys called receive data. I can say, hey, it took 4 seconds. I can look at a job inspector to get a visual idea of exactly what happened throughout that process. I can click on the edges to get an idea of the metadata coming through. But on the server, we ourselves don't persist any of the information. So if you're looking at more sensitive data, we never sort of persist that data for data throughput. There's ways to basically hide the debug information of the different records so that we don't appear on the server at all. But we can also track the record throughput through the tracking tab as well. It'll let me know how much data we're pushing through at different points for logging or sort of BI tools you can integrate with as well, along with the log file. When things do go wrong, it'll highlight it in red here. And for example, we can go through the job inspector and see specifically, hey, what problem did we have, right? So we're going to go through the overview. It'll give me pretty specific error handling. Like I couldn't instantiate a connection to a Redshift instance in this case. So it's, from a developer's point of view, incredibly easy, much easier than trying to script things out and hoping and praying that it runs correctly. It's really specifically allowing me at a component level to dig down into what went wrong, why it went wrong, and what I can do to fix it. Super helpful from that point of view. And like I said earlier, we're trying to automate all these processes as much as possible, right? So there's a few different ways to do that. We can schedule things like any chronological sort of job that you can think of. We can schedule this way. So I can say, hey, I can start a job flow graph, an email, and actually other parts as well, right? So I can execute shell commands, integrate and orchestrate other processes of my organization as well. So again, we're sort of trying to be that data backbone of any organization. We have event listening, which can trigger jobs based on things like a Kafka message coming in, JMS message, a file showing up somewhere. So I can basically listen for an incoming file on an Amazon S3 bucket or an SFTP site. I can just put in the credentials, and every time a file's added, changed, removed, etc., I can have that trigger a job, right? So if it's a spreadsheet, it'd be this file name pattern match that I would then use to look every 60 seconds, and then I can trigger a task from there, which is really helpful, sort of again orchestrating larger processes around that. And then finally, something that's really cool is that we can actually host any one of these jobs here in CloverDX. I can show you what that looks like on the design side as an endpoint on our server. And what I mean by that is we can create what's called a data service. So I have this graph for you guys, and I wrapped it in a data service so that every time this endpoint gets hit on a server, we'll have it come through and run this job. So I'm intaking parameters from an API endpoint on my server that I've configured using this visual tool here. So I can say, hey, here's the endpoint. You can use get, put, post, whatever you need to do. I'm expecting these 3 different parameters, and I'm going to give the response in JSON, XML, CSV, even the raw file format, so that these jobs can be triggered via API calls on the server. So it's really, rather than sort of sit around and wait for incoming files or schedule to hit something, we can call these jobs ad hoc whenever we want via API call, and design essentially our own API endpoints. In this specific case, I'm using an API endpoint to also trigger a call to another API endpoint using the dynamic queries from the request to create a dynamic SQL query that I can then use on my DB. So just an example of some of the more complex things that we can do. And this is really just scratching the surface of some of the stuff we can do. But we can sort of build in logic so that we can get into a code approach or a scripting approach to really get what we want out of this, right? And that's all sort of handled here on the server side in our data services tab. To take that one step further, we also have what are called data apps. So we can extend our data services with sort of visual data apps so that people like, let's say, a non-technical business user could utilize us from an API perspective to get the data that they need ad hoc. So think of like self-service data. We can completely handle that in data apps. So for example, if I'm a non-technical business user, I can take this endpoint to intake a list of emails, perform a database lookup, and return customer information. I, as a non-technical business user, can go through, drop a file, which is just a CSV file of emails. And in the background process, I'll have a data job designed here in CloverDX that looks like this, where I'm basically intaking, that raw file. It's going to look like this. It's going to come from the request part. And then I'm going to use it to do a lookup join on a sort of customer DB and write out a spreadsheet as a response. So that's what it looks like from the data engineering perspective. From a business user's perspective, I'm just uploading a file. I run the application. The magic will happen in the background. I'll be hitting that API endpoint, getting the data that I need out of it. It'll be running, and then I'll grab the response file that looks like this. And it'll basically, what I did here is I uploaded this email, and then I did the DB lookup to get all my enriched customer information here all together. So that's another possibility, sort of self-service data applications. And really, we're just sort of scratching the surface here really quickly on this webinar. But there's a lot of different possibilities on how you want to run things and sort of create your ideal data scenario and run things that way. So with that, I'll go ahead and turn it over back to you guys. If you guys have any questions, feel free to pop them in the chat. Happy to sort of talk through anything that you guys might have.
Thanks, Calvin. Yeah, and if anyone does have any questions, do just pop them in the Q&A box, and we will throw those over to Calvin for some answers. While everybody's doing that, I'll just pop some links in the chat box here for some of our upcoming webinars. So every Tuesday, we hold a webinar on a different topic around data. As you can see, next week, we're doing one around the topic of data ops and how you can kind of move your data pipelines towards the DevOps and data ops approach. And then we have 2 sessions on migrating your data to the cloud. One if you're looking at AWS and the other one if you're looking at Azure. So the links are there. We'll put those in the email where we send out the recording too. So if you want to come along, just come and register for those. We'd love to see you. And cloverdx.com/webinars there is our webinar library where you can watch all of our previous webinars on demand, and you can also sign up for anything we've got coming up. So let me just check the Q&As. Looks like we do have one question here. Can you create workflows to sequence the tasks?
Yes, so sequencing tasks looks something like this. Actually, I think I did this over here. Yep, on this one. This little button, this little number here in the corner is what we call phases. So in this sequential sort of phase, I have 0, everything in 0 is going to execute before everything in 1, and 1's going to execute before everything in 2. So in this case, we're reading the database first, then the CSV, and then hitting the API endpoint. So that basically, you can stretch them out and do sequential things as well that way. Good question.
Yeah, thanks for that. I hope that answers the question. And just say if anybody does have any questions that maybe they don't want to ask in public, or maybe they're a little bit more complicated and you'd like to chat to someone about something, then I've just put the link there for our contact us page, and you can always drop us a message and we'll get right back to you. Oh, and a follow-up question from the previous one, Calvin. Dilip is asking, this is one ETL job, but a number of jobs to glue together.
Yeah, so there's different ways to sort of get things going. This is one job, right? But to give you an idea of some of like the complexity of, I try to use a pretty simple example just to get things going, but you can tie them together and actually wrap this whole thing as a job that you can call sequentially. So like if I wanted to build, for example, a data warehouse, right? It would look something like this, and it's actually a sequence of different jobs that are running, in parallel or sequentially, depending on how you, design it and thread it out. So let me see here. It would look something like this. So this is a data warehouse example where I'm basically triggering things as files show up to a location. So again, I'm getting an XML file, a text file, another text file, and then we're loading into a data warehouse, right? That data warehouse main process looks like this. And it's really a couple different jobs being stitched together. I'm moving things to a process directory, running a data warehouse loader, and then archiving them. The loader looks like this. And each one of these is a completely different job that's handling something else, right? So I'm stitching different jobs together, and I can drill down into each one of these and show you, like, for example, I'm intaking employees and doing a change data capture environment here, where I'm comparing records, doing inserts versus updates versus new things, right? So you're sort of, yes, stitching them together in a lot of ways to make more complex jobs possible. Like this is a very robust enterprise level data warehouse that I have working. So there's different ways to do things. But yeah, that's sort of, that's a good question. Yes, you can stitch them together, but you can also package them together as well to then stitch together later. So lots of different possibilities.
Cool, thanks, Calvin. Let me just check and see if we've got any other questions that have come in. Okay, I don't think we have any other questions today, so we will wrap up and let everybody get on with your day. So thank you very much, Calvin, for the presentation, and thank you to everybody who attended. It's great to have you here, and we hope to see you on another one of our webinars soon.
Sounds good. Thank you so much. Cheers, guys.